Hey everybody, welcome back to another video. In my last video, I did allude to the fact that I wanted to do another video soon in which I would kind of give my own comments and thoughts on an interview that I watched a while back between Lex Fridman and James Gosling. If you don't know, James Gosling is the father of Java. He is the lead developer behind the whole entire Java project that was started at the now defunct company Sun Microsystems. Java is now owned by Oracle, but Sun Microsystems started it. So James Gosling was the lead developer. He's the guy who is credited most with having created Java. And there's an just amazing interview in which he kind of takes us through the past of how Java was developed, why it was developed, what he was thinking, and so on and so forth. I think this is such a useful thing to know as a developer, not just of Java, but of any language. It's always helpful to understand why was that language created? What problems was that language trying to solve, or the creator of that language? When you understand that, you then have a better appreciation for how best to utilize the language today, or why we're even using it. So I think there are many awesome insights to be gained by watching the full interview, but I'm just going to show excerpts from the interview and then give a few of my own thoughts here and there, okay? But before I do that, let me remind you guys, on February 14th, 2023, that is Valentine's Day, at 11:30 a.m. Central Standard Time in the US, which is 5:30 p.m. or 17:30 in London or UTC time, I am holding a free webinar. I invite everybody to come. Did I mention it's free? It's free and it's a webinar. And the main idea behind it is to get a chance to meet everybody live and to let you know about additional services that I have now through my newly revamped website. I have a 12-week boot camp. I've already started the first 12-week session of that boot camp, and I'm gearing up to start up a second 12-week session at the beginning of March. I think it will start March 2nd, if I'm not mistaken. So come to my free boot camp and let me tell you more about it if you are interested. Why might you want to do a 12-week boot camp, by the way? Let me tell you, that's a good question. Well, maybe you're already trying to learn Java. Maybe you're in my course. I've got a lot of people on this channel who are already taking my Java Foundations course. But, you know, very few people actually ever finish these online courses. It's just a fact of life, right? And so maybe it would be helpful for some of you to be in a once-a-week class where you can be kind of held to account a little bit, or just helped to get through the entire 90-hour course, okay? And then there's some additional benefits that I can offer, but to find out about those, you need to come to the webinar, okay? So follow the link in the description below this video, and that link will let you register for free for the webinar, and then come and meet me in that webinar on next Tuesday, February 14th, 2023, and you'll find out all of the awesome benefits of the services that I have to offer. Or you can just ask me questions and just come and meet me. Either one, I'm cool with it all. It's all good. And then also you can check out the link for my website in general, where I do have my courses and other things that you can come and enroll in. And right now I'm offering my Java course for a really, really crazy low price of $9.99. So if you hurry up and come and click on the link and go grab that course while you can get an amazing deal on that course. I won't have that there forever, okay? So without further ado, let's jump into the interview with James Gosling.
How did it become this incredible, powerful language?
We sort of discovered that there were some things about standard practice in C programming that were really getting in the way. And it wasn't exactly, because we were writing all this C code and C++ code that we couldn't write it to do the right thing. But, there were a bunch of things that were going wrong, things that were going right. And, as we thought about, things like the requirements for security and safety, some low-level details in C, like naked pointers. So back in the early 90s, it was well understood that, the number one source of security vulnerabilities
It's pointers.
was just bugs.
Yeah.
right? And it was like, 50, 60, 70% of all security vulnerabilities were bugs. And the vast majority of them were like buffer overflows.
So you're like, we have to fix this.
We have to make sure that this cannot happen. And that was kind of the original thing for me, was this cannot continue.
All right, so you hear him mention the concept of pointers a couple of times right there, and the fact that the number one issue with software back in those days, and I might argue possibly even now, was buffer overruns and pointer issues, okay? So let me attempt to give a quick explanation of what a pointer is. So basically in programming, I'm not even talking Java, just in programming in general, anytime you refer to any kind of data within a program at all, for example, if I write a program that asks you to enter your first name and your last name, and then later in that program, I print out your first name and your last name along with a welcome message or something like that. In order for me to do that, I needed to grab your first name and your last name and hold on to them somewhere. Now, where I will hold on to what you entered is in memory of the computer. And to do that, I need to ask the computer to give me some memory to hold this first name and this last name. Okay, so I will ask the computer, hey, find some empty, unused space in your memory, and then tell me where that space is and allow me to store a first name and a last name in that space in the memory. What will happen is that the computer will return to me when I ask it to give me that space. It will return to me an address in memory of where I can use that space. Okay, so it gives me a free location in memory as an address. I will take that address and I will store it in a different type of memory. I'm intentionally not using all of the technical terms here because I just want to explain the concept. But I will take that address and I will jot it down in a different, more temporary type of memory, okay? And so now that address that I've written down points back to wherever in the normal system memory the system has found for me to store the first name and the last name, okay? So I'm just asking it, find me some free space in your memory where I can, store the first name and last name. Give me the address of that. Then I write down that address somewhere else, okay? That address and the place where I wrote it can generally be thought of as a pointer because it points back to wherever the first name and last name are being stored in the system memory, okay? The problem is with slightly older and somewhat more low-level languages like C and C++, when you have these pointers that are pointing back to memory, the management of these pointers and the memory that they point to has to be done by you, okay? And you, I don't know if you know this, but you are human. We are human. And humans actually aren't that good at keeping track of non-trivial amounts of information coming in and out of a system at any given moment, okay? We're just not very good at doing that. And so what can happen is that sometimes we will forget to write the code that will, for example, free up the memory when we're done using it, okay? Because you have to give that memory back when you're done using it. So sometimes you forget to give the memory back, and that may be called a memory leak, where you're just constantly asking for memory, but you're never giving the memory back to the system. And eventually your program crashes because it asked for all of the memory in the system, for example. Now, that's not likely to happen in a program that's just asking you for your first name and last name, but I'm just giving you an example there. Or you think you're freeing up the memory, yet other parts of your program continue to write to that memory, okay? So that could be a problem as well. And there are a number of other ways that you could do stupid things with memory that you are managing within your program, okay? And that's basically what James Gosling is talking about here. And I think we'll hear him mention in a minute the fact that some of the biggest and most egregious security vulnerabilities in applications have to do with mismanagement of pointers and the memory that they are pointing to, okay? And so 30 years ago, he was recognizing that considerable amounts of time, money, and resources were being wasted by companies and organizations because developers were having to do battle with basically themselves, right? Having to do battle with the fact that they wrote code that might not have been managing pointers and memory allocation as robustly as one might have hoped. And so you end up with bugs or vulnerabilities, and then you have to waste a lot of time trying to hunt those down and fix them. And a lot of those bugs can be some of the most difficult things in programming to fix, okay? So it would be nice if you could make it easier to handle the management of the memory and all of that, okay? All right, so let's continue.
One of the things I find really entertaining this year was, I forget which rag published it, but there was this article that came out that was an examination. It was sort of the result of an examination of all the security vulnerabilities in Chrome. And Chrome is like a giant piece of C++ code. And 60 or 70% of all the security vulnerabilities were stupid pointer tricks. And I thought, it's 30 years later and we're still there.
Still there.
And we're still there. And, that's one of those, slap your forehead and just want to cry.
So would you attribute, or is that too much of a simplification, but would you attribute the creation of Java to to C pointers? An obvious problem.
Well, that was one of the trigger points.
Concurrency, you've mentioned.
Concurrency was a big deal. Because when you're interacting with people, the last thing you ever want to see is the thing like waiting, and issues about the software development process. When faults happen, can you recover from them? What can you do to make it easier to create and eliminate complex data structures? What can you do to fix, one of the most common C problems, which is storage leaks, and its evil twin, the freed but still being used piece of memory. You free something and then you keep using it.
Oh, yeah.
So when I was originally thinking about that, I was thinking about it in terms of sort of safety and security issues. And one of the things I sort of came to understand was that it wasn't just about safety and security, but it was about developer velocity, right? So, and I got really religious about this because at that point I had spent an ungodly amount of my life hunting down mystery pointer bugs.
Yeah.
And, like 2/3 of my time as a software developer was, because the mystery pointer bugs tend to be the hardest to find because they tend to be very, very statistical. The ones that hurt, they're like a 1 in a million chance.
But nevertheless create an infinite amount of suffering.
Right. Because when you're doing 1 billion operations a second,
yeah,
1 in a million chance means it's going to happen. And so I got really religious about this thing about, making it so that if something fails, it fails immediately and visibly. And, one of the things that was a real attraction of Java to lots of development shops was that, we get our code up and running twice as fast.
You mean like the entirety of the development process, debugging, all that kind of stuff?
Yeah. If so if you measure time from, you first touch fingers to keyboard until you get your first demo out, not much different. But if you look from fingers touching keyboard to solid piece of
Stable.
software that you could release in production, it would be way faster.
And I think what people don't often realize, there's things that really slow you down, like hard to catch bugs probably is the thing that really slows down that.
It really slows things down. But also there were, one of the things that you get out of object-oriented programming is a strict methodology about, what are the interfaces between things, and being really clear about how parts relate to each other. And what that helps with is so many times what people do is they kind of like sneak around the side. So if you've built something and people are using it, and you say, well, okay, I built this thing, you use it this way, and then you change it in such a way that it still does what you said it does. It just does it a little bit different. But then you find out that somebody out there was sneaking around the side.
Yep.
They had sort of tunneled in a back door, and this person, their code broke.
Yep.
And because they were sneaking through a side door. And normally the attitude is, dummy. But a lot of times, you can't get away. You can't just slap their hand and tell them to not do that.
Right.
Because, it's, somebody's, some bank's, account reconciliation system.
Right.
that some developer decided, oh, I'm lazy, I'll just sneak through the back door.
And because the language allows it, you can't even get mad at them.
And so one of the things I did that on the one hand upset a bunch of people was that I made it so that you really couldn't go through back doors, right? So the whole point of that was to say, if you need, if the interface here isn't right, the wrong way to deal with that is to go through a back door.
Yep.
The right way to deal with it is to walk up to the developer of this thing and say,
change the interface.
Fix it.
Yep.
Right. And so it was kind of like a social engineering thing.
So one of the things I think he's most alluding to here is the idea that in many other languages prior to Java, it was a little too easy for a programmer to call functions or methods of a library or an API that weren't really meant for you, the end user, to call. They are more like private methods and functions of that library. And the problem there is that if you as an end user are calling unpublished or private functions or methods of a library, those functions and methods are not guaranteed to remain stable for you to use, for one thing, okay? Because they're not meant to be public. They're for internal use by the developers of that library. So what ends up happening is that the maker of that framework or that library or that API decides to change some of the internal details of how that library is working. And in doing so, they delete or refactor or greatly change however that particular private function or method was working. Maybe they get rid of it. Maybe they just change it so drastically that when they push out the new version of that library, and then this organization, upgrades to that new library, all of a sudden their software is broken because they were, to use Mr. Gosling's words, they were going around through the back door and calling functions and methods that they weren't supposed to be calling in the first place, okay? And now their stuff doesn't work. And what they should have done is gone to the organization that wrote that library and said, hey, you've got some really useful functionality there that we'd like to use. Can you give us that functionality officially so that we can do whatever thing that we are trying to do? That's the right way to do it. And if they had done it in that way, they wouldn't have broken code now. So 30 years ago, that was happening considerably. So much so that Mr. Gosling sought to put an end to it. Now, you know what? Let's open up an IDE and let me actually show you a little example of what that could even look like. All right, so I've got here a quick little dummy class that I've just written called My Library. It represents, some library from, some organization or some company. And this class has two methods in it, a public method and a private method, okay? So the public method here called Get Useful Data is public, meaning that any code from outside of this class should be allowed to call this method in general, okay? But then I've got another method here, which this public method depends on, okay? And this one is called process data, but it is private, meaning it is not intended for outside code to be able to call. And in fact, outside code cannot call this method. Now, this is Java code that we're looking at, okay? So we're seeing like the mechanisms that Mr. Gosling was just referring to that he put into place to stop all of the nonsense and the shenanigans that he was just referring to, okay? But here's the deal. So 30 years ago, in some other languages, developers might have been able to spy on this code and see, oh, there's a process data method here. Or maybe it would have been a function back then if it were like, the C programming language or whatever. But anyway, they would see that there's this function or this method here called process data. Now, they might have understood that that really isn't intended for them to use, but there was no mechanism in the languages that they were coding in to prevent outside developers from calling that method or that function. And so if that method or function did something that they thought was useful, they might very well go ahead and just call it, okay? But in Java, by making this method private, I am able to prevent outsiders who aren't me from ever calling that method, okay? Especially once I package up this class into a deployable library like a jar file and then distribute it out on the internet for other people to use. This method being private means that they will not, under normal circumstances, be able to easily call that method, okay? And then there are other things that I could do to prevent that even further, but that's the gist of what he's getting to. And so just imagine now, if someone had written code that was depending on this method being here and working in exactly this way in version 1 of this library, but then in version 2, they decide to change this. And let me show you how they might have changed it. I'm going to do something called inlining. Look at that. I just changed this code so that I don't even need that method anymore, the private method, okay? And now everything is just happening here. Well, if I did that in version 2 of this library, and then I distributed version 2 of my library, what would happen to all of the code that had been referring to my previous private method? That code would break, right? Because it would now be trying to refer to a method that no longer exists in version 2 of this library, okay? And that's the basic thing that was happening back in his day. And it actually does still happen today because there's plenty of software. It happens all the time, like in operating systems. Operating systems have methods and functions that are part of the public interface, and then they will have private methods and functions that are not meant to be public, but developers will go in and find these things and realize, oh, wow, I could make a program do whatever if I called this unofficial, private function or whatever. And then in the next version of your operating system, when that comes out, they decide to change how all of that works, and now your code no longer works. Okay, so that's one of the reasons why you really should be careful about writing code that is calling backdoor functions and stuff that weren't intended for you to be using.
It's brilliant.
And people ended up discovering that really made a difference in terms of, and a bunch of this stuff, if you're just like screwing around writing your own, class project scale stuff, a lot of this stuff isn't quite so important because, you're, both sides of the interface. But when you're building, sort of larger, more complex pieces of software that have a lot of people working on them, and especially when they like span organizations, having really having clarity about how that stuff gets structured saves your life.
Yeah.
All right. And that is such an important point that he just made there, and one that I often like to try to reiterate, especially to younger, newer developers, because I get the sense that there is a contingent among some of the newer, younger developers that they may not fully appreciate what a language like Java is doing, especially because it is now pretty old, right? It's kind of like, pushing 30 or whatever. And they've grown up kind of doing like little kiddie scripts in Python and JavaScript and languages like that. And I think, I don't know for a fact, but I get the sense that some of them look at a language like Java and feel like it looks really bloated and overblown. And I think if what you have been growing up doing most of the time is small little, website apps and website applications, like just tiny little things for yourself, or, just your own little personal projects, and not like, enterprise level corporate banking software that can never fail and it needs to work robustly and be fast and efficient and all of that, right? If you've never worked on that kind of stuff, and you've just done little projects that you can do like in your own home, on your own, by yourself in your mama's basement, it's going to be kind of hard to fully appreciate what a language like Java is really bringing to the table. And other languages these days, other more modern languages as well. So yeah, I mean, that's an important thing to understand, though, that this language, Java, was created in large part, not just to solve some of the problems that he was talking about, but also with larger scale enterprise level projects in mind, okay? Not like the little tiny application that a 15-year-old can write in their basement, right? In an afternoon. You can use Java for that too, but it might feel bloated, right? And some of that bloat is the fact that Java has a lot of guardrails that you can utilize to protect your code from other developers on the same team, right? So when you're working on a large application with lots of developers simultaneously, and especially, and this is an important point, not all of those developers on that team are geniuses, right? You got some really smart ones and then some average people, and hopefully not too many below average, but you've got a swath of different types of developers on a team, right? And you all have to kind of play together in the same sandbox. So having a language that prevents, pardon me for saying it this way, but that prevents the stupidest person on the team from doing too much harm and damage to the overall application, that's not a bad thing in the corporate world. However, it means that language is going to come with more strictness, more guide rails and things of that sort. And, if you're just a 15-year-old kid trying to just quickly do some little whatever in an afternoon, yeah, that stuff might get in your way. If you're an adult working for a bank that can't fail, you need that stuff, okay? And that's basically what he's getting at there.
And, especially, there's so much software that is fundamentally untestable, until you do the real thing. Right.
It's better to write good code in the beginning as opposed to writing crappy code and then trying to fix it and trying to scramble and figure out and through testing, figure out where the bugs are.
Yeah. It's like which shortcut caused that rocket to not get where it was needed to go.
All right, so that about covers what I wanted to show for now in that particular clip from James Gosling. The original interview, by the way, was, it was pretty long, hour and a half, maybe two and a half hours. I don't recall. I will post a link in the description below this video, though, to the full video and then to a couple of the clips as well. And there's another clip that I would like to probably review as well, but I will save that for another day, maybe sometime next week or so. But yeah, so this was pretty cool, right? It just helps you to have a better appreciation and understanding for why is Java the way that it is. And then languages that have come after Java now that borrow a lot of the strictness or the guide rails that Java really popularized. I don't want to say Java necessarily invented a whole lot of new things, but it certainly popularized things. By the way, I'm sorry, I totally forgot to even mention with the memory pointer stuff, the real thing I would say that James Gosling and his team did to fix that or address that issue was automatic memory management, okay? So what James Gosling and his team did for that was to basically come up with a robot that manages memory for us. So we don't need to explicitly ask the operating system to give us memory when we need it. We just refer to things that require memory, and then this memory management system of Java's understands that it should go ask the system to get that memory, to get some memory for us and allocate it and then handle it, okay? And then when we store data in a variable, those variables in Java are frequently, unless it's a primitive, in effect, pointers. But we don't need to be consciously aware of the fact that we are essentially dealing with pointers. And perhaps most importantly, we are not permitted to do all of the points, as he called it, stupid pointer tricks that you can do in languages like C and C++, where you could have a variable that is a pointer that points to a first name, and then you could take that variable and add +1 to it to point to like the next address location in memory. And so you can start doing like pointer math and things, which is really cool, but it also introduces an additional level of complexity in your programs and opens your programs up to the possibility of more bugs if you get that math wrong, which developers, I don't care how smart they are, get wrong all the time. It's just really easy to do. So Java manages the memory for us, and very importantly, it can sit there and track when we are no longer utilizing any of the memory that it allocated, and then it has what's called garbage collection, where it will just automatically, it will see, oh, you're not using this anymore. None of this code is using this piece of memory over here anymore. So I'm going to go ahead and clean it out and give that memory back to the operating system so that there is less of a possibility of a memory leak. Okay. So Java really popularized, it did not invent, but it did definitely popularize the use of these ideas and these concepts to make developers much more productive. Okay. All right. So that's all I wanted to cover for this video. And like I said, maybe I'll try to do another follow-up on this next week or at some point in the near future, okay? But I thought this was a cool one. I've been wanting to do this little video for a couple of months now, in fact. So I'm glad I finally got a chance to do it. Hopefully you liked it. And let me just remind you again, check the links in the description below. Come visit me at my website. Come register for my upcoming free webinar on February 14th. That's Valentine's Day 2023, so that you can join me for free for my webinar, and I can tell you a little bit more about some really cool additional services that I can offer you. Come check out my Java Foundations course if you want to learn Java. It's super important and useful language. I hope you now have a little bit better appreciation for it, in fact. So, my course is 90 hours long. It's probably about one of the most comprehensive Java courses that you will find anywhere on the internet. And one of the really cool things about it is that I try to stay pretty on top of the latest innovations in the Java programming language. Okay, so I'm not just teaching like the old stale stuff that you could have done it with Java 15 years ago. I'm teaching pretty much the latest innovations that have come out in the last year or two with the language. Okay, so definitely come check that out if you haven't already enrolled in my course. All right, and with that, I'm going to sign off, and I will see you all in the next one.